Welcome to the shop. I'm continuing NQALHA Production Run 4, making 750 custom-made parts. The parts made from aluminum extrusion are complete, and I have a few more pieces to make from aluminum sheet, but now I'm moving on to the steel parts. Today I'm in the lathe room working on the axle for the vertical arm. And I'm going to be grinding down some half-inch steel shaft material. The vertical axis, the vertical axle for the NQALHA has to fit into a bearing bore, and a bearing bore is fairly precisely machined and ground. The stock that I get, cold rolled half-inch rod, is reasonably accurate, but when you combine the manufacturing tolerance of cold rolled rod and then add on top of that nickel chrome plating, well, it doesn't fit into the bearing. So I'm reducing the diameter by about 5/1000ths, and I'm using the tool post grinder over on the manual lathe. I probably could have just used sandpaper and not gone to the trouble of setting up the tool post grinder, but I'm trying to see how much more precision I can get, and just, bit by bit trying to improve my machining skill and my ability to make precision parts. So even though it doesn't, strictly speaking, doesn't require the tool post grinder, I'm using it anyway just to get some practice. It's not a tool that I use frequently, and seems to do a very, very nice job. So let me get the camera moved over here. For those that aren't familiar with tool post grinding, it's a method of producing very high accuracy, very good surface finish, but it doesn't remove a lot of material. I'm going to be taking about 1/1000th per pass. I want to reduce the diameter of this rod down to about 496, about 4/1000ths under, which will allow plenty of clearance for the nickel chrome plating, and the fit to the bearing doesn't have to be ultra good. I mean, it doesn't have to be like a press fit or a tight fit. It just has to be a fit that has enough clearance that I can assemble the units. The shaft is not going to be spinning at high speed. It doesn't have to be precisely balanced. All I'm trying to do is just make sure the shaft will go in the bearing and it's not too loose and too sloppy. So I put a piece of wood under the grinding wheel to kind of protect the ways, and then I've got a paper towel here, and I periodically wipe off any grinding dust that I see, because grinding dust on the ways is not a good thing. Using a digital readout, and I've already done a couple of passes and adjusted the tailstock to give very good parallelism across, and when I measure the diameter with a nice quality micrometer, it's within a few tenths over the entire distance. If I really wanted to make it like really, really good, I'd probably use a follow rest for the unsupported section in the middle, but taking a light cut and just being careful gives the result that I need without having to go to that much trouble. I'm using mist coolant, and let's get going here. Kind of hard to do any work with the camera setup like this, but normally when I work I don't have a camera in place. So here goes. I'm going to dial in Okay, so I've got it set for 496, got the mist coolant on, and gonna be taking roughly about 1,000th or so. Definitely don't want to try to take too much with this setup. First of all, tool post grinding is not good for heavy removal just in general, and with a thin piece that's unsupported in the center, it would be a really bad idea anyway to try to take a heavy cut. So I'm thinking 1,000th is about the most I can safely do. I had to dress the wheel at an angle and mount the tool post grinder at a slight angle to clear the tailstock, but everything appears to be working very well, and when I measure the part with my high quality micrometer, not some El Cheapo piece of Chinese junk, it's a nice high quality Starrett, I'm finding that the dimension is pretty good. It's definitely within a thou, actually, within probably a half a thou end to end, which it doesn't need to be, but, it's always nice to, more precision I can get, the more practice I can get doing precision work, the better off it's going to be. So that's about all there is to this. It's just light cuts, be very careful, watch what's going on, keep the grinding dust off the ways, and then once the material is prepared and inspected and I verify that it's all the right size, I'll cut it to length, weld a piece of 1-inch steel on the end, and finish the operation on the mill. So that's about all there is to see here, not that exciting. The vertical arm axle is made of a combination of two pieces of steel welded together. The main body of the axle is 1/2-inch cold-rolled steel rod, but the bottom piece is 1-inch cold-rolled steel rod drilled and welded onto the bottom. So I have a piece of 1-inch cold-rolled stock chucked up in the collet chuck, and I'm going to be using mist coolant, using a stubby drill, so I don't need to use a pilot hole or a center drill. The hole doesn't need to be centered precisely within a few thousandths. The hole doesn't need to be precisely on center within a few thousandths, and using this stubby drill gives me close enough. I am using a pilot drill. I'm a little uncomfortable drilling the half-inch hole in one step. I have a digital readout on the tailstock so I can see roughly how far I'm drilling. I occasionally pause to do some chip breaking, and if it looks like the chips are starting to get clogged up, pull the drill bit out and stick it back. It'd be a lot nicer if I had a turret. Maybe someday I'll get a turret for this thing. Maybe someday I'll get a real CNC lathe. Who knows? A little pause here and there breaks the chips. Looks like I'm getting nice chip formation. Looks like the drill is drilling nicely centered, at least well enough centered for what I'm trying to do. I'm going to put a chamfer on it using this big countersink. Kind of gives a nice place for the weld fillet to form. So next I'm going to part it off and go over here and just touch off the parting tool. Set the DRO to 0 and then move over to the distance that I need to make, and then of course I'm adding the size of the parting tool and using a carbide parting tool. Pausing to do a little chip breaking. Looks like the chips are forming nicely. Off camera, while I was setting up the machine, I did indicate the tool holder to be perpendicular so I don't get binding on the side of the parting tool. Still getting fairly nice chip control. Nice surface finish. And the part falls off. So I'm going to run the other 9. Then I've already use the tool post grinder to size the half-inch stock. So the next step is to cut it to length, put it in a welding fixture, and TIG weld it together. Then it's off to the Bridgeport to do some milling. So, see you later. Well, I'm getting set up now for TIG welding. I've got a magnetic welding clamp stuck to the bottom of the welding table, holding up the shaft, which then protrudes through a piece of 1.5 by 1.5 square tube, and then the part that I just made on the lathe sticks on thusly, and I'm using a TIG welder, 100 amps, with a gas lens, and I do have a filler rod here just in case, but typically the weld really doesn't require any filler rod. It usually just, the material on the end of the shaft fills in the fillet and makes a very nice weld. So you probably, I don't have a proper filter set up to be able to actually give a close-up of the welding, but oh well, can't do everything. I've used a little bit of filler rod just to start the puddle going, but once I've established a nice puddle, we don't need any more filler rod. And that is a nice weld. So, got 9 more to do. Then it's off to the milling machine to drill some holes and cut some flats and continuing. Progress continues. Okay, I've set up the Bridgeport for this operation, and there's 2 reasons that I'm using the Bridgeport. First of all, the Tormach is currently set up for the rapid turn, and changing between rapid turn and mill is such a royal, enormous pain that I don't like to do it very often. And like I keep saying, maybe someday I'll buy a real CNC lathe and not have to go through with that. So I've set up the Bridgeport using the Heimer indicator, did that off camera, and I've set this point, the typical point that I always use, which is the rear left corner, set that up as the 0 reference, and I'm going to be drilling some holes. On this part, now that it's this welded assembly, this is the reference, and I'm going to be using 2 different references depending on which operation I'm performing, and there's a reason for it. When I'm drilling the holes that will be the holes in the shaft, I have the reference set to the inside corner of the part. When I'm drilling the hole through the part that's going to attach the magnet bracket, then I have to reference from the outer diameter of the 1-inch piece, because even though the hole was drilled on the lathe and it's, you know, moderately accurate, I really want the hole to be accurate relative to the face, because, you know, I don't know really I didn't machine that diameter. The diameter is whatever diameter the stock is, and so it might be off 1/1000th or two, and then the hole is, you know, it was just drilled, it wasn't reamed or bored. And so if I want to have the through hole for the axle be precisely located relative to the face, I have to reference from the face when I'm drilling that hole. But the holes I'm going to be drilling now need to be referenced to the center of the shaft, and so I'm using that point. So once again, the Bridgeport control system, I'm using Mach 3 with a custom-made screen that even has my logo on it, and I just loaded the toolpath from the network so I don't have to carry USB sticks. Or when I originally got the machine with the old NLM control, it had a floppy drive, and you can imagine, you know, not only are floppies obsolete and impossible, almost impossible to find, they don't last long in the machine shop. So go over here to the first hole. I'm gonna set the Z0 at the top of the part, and I'm gonna be drilling 5 holes. The first hole goes all the way through, second hole goes halfway through, and then the next holes go all the way through. Even though it is steel, I'm using 4,200 RPM because the drill bit is a very small bit. And just pecking by hand with mist coolant. It is a fairly deep, small diameter hole. So I've got to be a little bit careful to not burn up the drill bit. This next one only goes about halfway through. Doesn't have to be within 1/1000th or anything, but it doesn't go all the way through. So just roughly 0.5. Just peck by hand, peck, peck, peck. Get a nice tip control. Drill bit remains clean. So this is the first operation. In the second operation, I'm going to turn the part over and mill a flat. Then for the third operation, I turn the part 90 degrees and drill that hole I was talking about before, the 1/4" axle hole. So I'm going to finish up, run all 10 parts, get the setup ready for the next operation, and see you later. All the holes are now drilled. I made a fixture that kind of looks like that, and a couple of pins sticking out of it, and going to be locating the holes I just drilled into the pins, or the pins go into the holes, I should say. So 0 point is still at the left rear corner. Got a tool path constructed here to mill the flat, and it's going to be using a solid carbide 3-flute cutter running at about 2,800 RPM, 10 inches per minute, with a depth of cut of 0.1 inches. Because I have less experience machining steel, and also because when I try pushing it, I usually end up burning up cutters and breaking cutters, I'm being pretty conservative here. Yeah, I probably could go faster, especially on the Bridgeport, because the Bridgeport has excellent rigidity, but yeah, if I go slow, I'm guaranteed that everything will be okay. I'm using the Z-axis quill stop that comes with the Bridgeport, so I don't have to manually adjust with the quill lever to get my 0.1 depth of cut. And of course, the depth of cut is not ultra critical, and if it's a few thousandths off, who cares? The point is, I need to make a flat mounting surface so that the magnet plate can screw on. So here's the part so far with holes and a flat. The last operation will be a perpendicular 1/4 inch hole going through this way, referenced to that surface. So, see you later. So all the holes have been drilled from this side, and the flat has been milled on this side, and now it's time to drill a perpendicular hole referenced to this surface. So in order to do this, I'm reusing the fixture. And as I showed a little while ago, the fixture has a couple of alignment pins. What I'm trying to do here is reference from this surface and that surface. So this corner will be 0, 0. So take a piece of bar stock, use it as a thick parallel, put my little a piece of aluminum over here clamped in place. Eventually, one of these days, I'm going to drill some holes in the vice jaw so I don't have to use a clamp, but hey, clamp works. Then fixture goes up against the stop. I milled a little piece here to fit against the flat. So now I'm pushing everything toward the stop, clamping in place, and then off camera, I use the Heimer indicator to set the back face of the vise and the side of this part as 0. So now I should be drilling my hole in the right place. Now, if anybody remembers, I don't know how closely anybody is paying attention to this, but there's an aluminum piece, the horizontal arm magnet bracket, that has a 1/4 inch rod that forms an axle that allows the magnet to move just a little bit up and down so it doesn't drag on the plate when it's de-energized. And the holes in the aluminum part are reamed to get a nice tight fit on the little axle, but in this case, for this part, I'm just going to be drilling with a drill bit. And you might wonder, well, why aren't you reaming? Because in this part, there's a set screw that holds the axle solidly in place, and so, you know, a teeny bit of slop is okay. It's taken up with the set screw. So I've got my DRO set up, and the hole should be in the proper place. Looking here at the DRO, and probably turn down a little, 2800 RPM. This is a high-speed steel cobalt drill bit. I usually don't use solid carbide drills. Maybe I should, but the cobalt seems to work really nicely in steel. And I'm peck drilling, being very careful to not burn up the end of the drill bit, and being careful to get good chip clearance because I am drilling all the way through a 1-inch piece of cold rolled. So there we have it. The hole, and nothing but the hole, so help me hole. Got a little bit of buildup on the drill bit. I'm going to go ahead and run the rest of the batch. Then gonna put the part back in the fixture that I used for milling the flat and do a little power tapping. I had a choice here of leaving it in the fixture and then changing from the mill cutter and doing a manual tool change, changing from the end mill to a tap, but boy, that's a big change. Then I gotta reset the speed, go into back gear, do a whole bunch of stuff. It's easier just to do all the milling operations, changing the part, not the tool. Then for doing my tapping operations, I'll just go ahead, set up the machine for power tapping, and put all the parts back in again. So I'll be back. All of the perpendicular holes have now been drilled, and I validated their correctness by assembling a magnet bracket to the axle using a 1/4-inch zinc-plated pin, and everything fits, all is well, everything is fine. Now I'm going to do some power tapping here, and actually, maybe I'm not. Maybe I'm going to take a little break and get some clearance. Clarence. Roger, Roger. I got the clearance, Clarence. The fixture just has a flat surface here, and if I try power tapping through, I'm not going to have a good day. So many things to think about. And I already had the machine set up for power tapping, and a bit difficult to get it back into high speed mode after switching to back gear. So going into manual operation. That's what I love about the Bridgeport. I can do manual work when I need to. And for some things, like doing clearance to a Sharpie mark, manual is all I need. should do it. Over to the Scotch-Brite and clean it up a little bit. So now, hey, that should be no problem. Love that power drawbar. It's actually faster to change tools on this machine than it is on the Tormach with its astoundingly slow automatic tool changer. So I'm slowing the tap way down. Back into, put the servos back into CNC mode. The nice thing about the annoyingly loud. The nice thing about the Bridgeport is when you push the E-stop button, it goes into completely manual mode. Servos are disconnected, works just like a manual mill. Don't need no stinking jog wheel. Don't need no dicking around with some kind of USB thing that can cause you trouble if you don't realize how it's connected. It's just old school wheels, and boy do I ever like that. I'm going to be using TapMagic Pro Tap for steel, and put some holes. The VFD allows really convenient reversing. All I do is flip the little toggle switch up here. Actually, just a moment to talk about things. Traditional Bridgeport has that little kind of like rotary switch, forward, reverse, and then the brake lever. Well, you can't use that with a VFD. The VFD needs to be connected directly to the motor, but the good news is it controls the motor really, really well. It controls acceleration and deceleration, and because I have a braking resistor installed, it can do a very rapid deceleration, dumping the rotational energy of the spindle into the braking resistor, so I don't have to use the little braking lever, and it just kind of goes when it's slowing down. I can also flip back and forth because I've got a little toggle switch up here, and I kind of get out of sequence a little bit, but the VFD must be remote controlled with control buttons that go to the control terminals on the VFD. So I made up a little box and wired up some wires with a start button, a stop button, and a reverse button. And it is oh so convenient. And there we have it. The part is now complete. Going to do a little bit of deburring, maybe hit it with the Scotch-Brite, and then it's off to the plating shop, and one more part can be added to the finished list. Boy, I'm getting close now. Probably just a couple of more days of work, and it's off to the anodizing and plating. So, thanks for watching. It's been fun.